Right, there we go. Hi, gents. Thanks again. Late night. Appreciate your time. Tonight's case, we are. Tonight's case is one of the cases that I've enjoyed most ever since I started participating in these kinds of competitions, because of the fact that I knew something about it, and because of the fact that it's got a bit of a meme cult following on the internet as well. I mean, if you Google the Game of Life, you actually get the Game of Life running across your screen on Google itself. So very cool. But yeah, this case was designed by our own Jason Weber. So Jason, like we discussed beforehand, maybe you can sort of share your screen and take us through the case and intro it, and maybe lead to tonight's session as well. Like I said last night as well, we will make we'll make this recording available on our YouTube channel, but you can also buy the cases from the actual store or the FMWC shop. And yeah, if you guys want to chat to us in the comments, or if you have any other suggestions, I think especially on this case, I think you had the opportunity to actually create a recursive lambda to solve especially the later levels and bonus 5. So if you guys have any cool lambdas that you want to share with us in the comments, please do. But Jason, the floor is yours.
Yeah, thanks, Renier. Yeah, good to do another walkthrough. I'll pull up my screen, but just maybe to give a brief background on the case. It's a case I've had in my mind to design for, I don't know, a year or more probably. And actually got the idea from a YouTube channel that I subscribe to called Numberphile, which is a bit of a nerdy maths channel about maths and numbers and stuff like that. And they did an interview with John Conway, the guy who actually designed this game, and he sort of chatted through sort of fairly informally about how the game was designed, and gave some of the backstory. And I just love the concept, and it's relatively simple in its sort of rules, but is essentially unpredictable, I guess, is the hypothesis. There are infinitely many potential outcomes, and unless you've got a really small starting stable set, it's quite difficult to predict what might happen eventually and whether things will come back or regenerate or whatever. I mean, I just find stuff like that quite cool. So in fact, in the case, I've linked to the Game of Life website, where you can go and put in a starting random array of active cells and hit play and see what happens. And it's quite fun. It's a little bit addictive actually to just go and play around, and then you're like, oh, well, what if I change one of these things? Anyway, so I've sort of been wondering for a while, how do we turn this into an Excel esports case? And I suppose, sort of touching on your point, Renier, how do we do this without breaking people's laptops? Because I guess if you try to run too many iterations, the calculation strain could become quite heavy. But I must admit, I haven't yet cracked the recursive lambda that I wanted to build to solve bonus 5. I ended up doing it much more sort of traditional modeling Excel approach, where I sort of laid out step by step and it sort of flows on. But certainly want to do that, and just understand, just for fun, see what the impact is on the calculation engine, and how many iterations you could kind of work through, how many generations you could work through, I suppose.
Yeah, I actually I was working on a recursive lambda myself, and I started with the reduce, and I had a sequence in there, and I thought I had it. I thought I had cracked it, but it just wouldn't resolve. So I sort of gave up after a while. But it is possible, and it must be possible. And I know that I think that Dim also he did it. He did a recursive lambda. I don't know if he did it under pressure, but knowing Dim, possibly. But yeah, I've also seen people do this in VBA, because it's also a perfect use case for VBA.
Yeah,
so
absolutely.
I don't know. I think you'll have to be very, very well practiced and versed in VBA to do it in the half an hour. If I take a couple of hours, I will definitely be able to pull it out in VBA myself, but not in half an hour. So then conventional modeling and sort of dynamic arrays with the new functions and functionality around it is a better option.
Yeah, I mean, Steyn, you're more of a VBA guy than I am, but conceptually, to me, the VBA is actually not that difficult. If you have one grid that's got hard-coded values and one grid that evaluates what's next, and you just then write the code to overwrite the hard-coded values with whatever comes next, that's pretty basic VBA actually. And so every time you run the code, it just keeps pasting. So in theory, you could do this fairly simply, I think, in VBA, but you would have to be confident enough to write the code under pressure. And I don't think it's overly complex code. Steyn, I don't know what do you think? I mean, it should be fairly easy, I think.
Yeah, no, I don't think it should be that complex, because especially if you just use VBA to just copy from the second table back to the first, and then you just loop it the X number of times.
Yeah, I mean, this is right up my wheelhouse, right? This is like project finance 101, infrastructure, funding, sizing, breaking the circularity, have a hard-coded set of information, run some calculation off of that, which actually refers back to itself, and they just keep hard pasting the thing until you kind of resolve the thing. That's pretty like bread and butter for us in the project finance space. And the code it's like one line, right? It's like make the starting range equal this range, all the values, and it's like done. And then this one remains live and it continues to iterate. And obviously this is a diverging range, right? So it's not converging to a point where you can kind of tell the thing to stop. It in theory will carry on into infinity. And so you have to, like, I don't know, specify how many iterations to run or whatever every time you hit F9 or I don't know, whatever. But conceptually it's not that difficult, I think. But most people, I suspect, would probably not have been confident enough to do that in VBA under pressure, and also because it was only really necessary, I think, for bonus 5. And by the time you get to bonus 5, you've probably got 5 minutes left of the case if you were fairly strong.
Anyway, look, it would have helped you. It would have helped you in level 6, 7, and bonus 5. But yes, I don't think it's necessarily unless you spent the whole half an hour on it. But I mean, I think you can do it with 3-4 loops. So you basically, the first loop is the number of iterations you want to run. The second loop is sort of rows, and the third loop is columns. And then essentially all you need to be able to do is to refer to the cells around it, do that calculation, and determine the state. So while you were talking, I'm thinking maybe I'll just write it tonight and do a little video on it, but we'll do it afterwards.
Here's a challenge, and Steyn and I will talk through the case, and then we'll come to you for bonus 5, and you can show us your VBA. No, I'm joking. Anyway, I've spoken too much about the intro. Let's sort of chat about the case. So, I mean, conceptually, I'll just go to grid 100 so people have a sense, and this is sort of quite a zoomed out view, but essentially you've got an infinitely tiled grid in the real game of life, and you have some initial cells which are alive or active as a starting position, and we've got the SAEC 2024 as a starting active cells, and then you've got a bunch of rules that apply, and we provided the rules. Essentially, I mean, there's a little bit of philosophy going on here. You know, if you've only got one neighbor or no neighbors, then you die by sort of solitude. If you have got too many neighbors, 4 or more, you die by overpopulation. But if you've got 2 or 3 neighbors, then you kind of have a healthy friend circle or whatever the case is, and you keep living. And if you start with a cell that is inactive as a reference point, then if it's got exactly 3 neighbors, then it becomes active on the next turn. Otherwise, it stays empty. And conceptually, I think to explain in sort of natural language terms, that sounds fairly straightforward. 5 basic rules that determine this infinite, unpredictable progression of ones and zeros, basically on an infinitely tiled grid. But as I think some of the contestants will have discovered on Saturday, I guess to model it and more so to model it in 30 minutes was more of a challenge, and we obviously then constrained the grid to not be infinitely tiled in all directions, because that wouldn't be practical. But for most of the case, we focused on a 10 by 10 grid, so 100 cells of information, and then I think it was only -5 that actually required the 100 by 100 grid. Anyway, so that's sort of the setup of the case. Maybe we'll jump into level 1, and I think one of the key points to unlock your ability to answer the case as a contestant for this particular case was the ability to split out a text string that doesn't have delimiters. So on just about all of the levels, I had provided a text string of 1s and 0s, which represented the active and inactive cells in the grid. And you had to then basically strip them out into the individual 1s and 0s, and then figure out how to wrap them into a sort of a 10 by 10 grid in most of the cases. And so understanding how you split out text was, I think, fairly important. I think you could do text to columns with a fixed width of 1, for example, as well, a little bit more old school. But the sort of go-to Excel esports formula of equals mid text, I should probably just do it on the side here, equals mid of the text, the start number that you want to put into the mid, you provide an array, the sequence, which is the length of the text. So that just says there are 10 characters in the string. So start at 1, start at 2, start at 3, start at 4 with a sequence up to 10. And then give me 1 character each time. And that will split it out. If you put the sequence into columns, it will give you columns, which is maybe a little bit more natural in the context of, which is maybe a little bit more natural in the context of an esports thing, but there you split out your text. And so that mid-sequence combination is quite a good one to know for splitting out text, particularly in these esports kind of setups. I don't know if you guys had similar approaches to splitting out the text, or if you did something different.
Yeah, I just wanted to show what I did additionally, because I redid the case today, and I just wanted to show the contestants or the participants, because I think more and more people are actually going to like pre-built lambdas, and they've got a whole tool set that they pull into the sheets, etc., before they start a case, and I just wanted to show people how simple it is, how truly simple it is. So what you just did, so I put the little formula text there, but what you just did was the sequence of the mid-sequence length, and then all I did was I created a little variable at the start. So if you go into the lambda, it actually asks for a parameter or a calculation to start with, right? So that's a parameter. The string is just a defined parameter, and then what I can then do is I can use that sort of like a let. I can use that as a named field within my formula again. So it's the same formula, mid sequence length, string 1, and basically to test your lambda, you put it into parentheses at the end. So all I did was I tested it on the first one, and then that's your answer, right? And then what you then do is you take that into your name manager. You can click on define name if you wanted to, but I essentially called it split string. You can call it whatever you want. I wouldn't call it text split because that exists, but you can if you wanted to. Then you'll have 2 text splits, and you'll be confused which one you're using. But essentially, all you do is you paste that lambda without the parentheses test in the end, and you click on OK. And what that enables you to do is you can then use the split string formula. And what's cool is you build it once, takes you a minute, and you can use it throughout your whole case. repetitively anywhere in the workbook, and that's the power. And then I said, well, it would be cool if you wrote this more permanent or a more permanent solution. Sometimes you want to split over rows, sometimes you want to split over columns. So if you wanted to take it one step further, you just put that. So you create you add a little bit of a flavor to it, where you basically just create in block brackets. You create an optional parameter. So the block brackets is what makes it optional. And then you can use the is omitted form function. I think is omitted can only be used within a lambda as well. Maybe not, but I'm happy to be corrected there. But all I did was I said, if it is omitted the value of over columns, then do it over rows. Otherwise, do it over columns. And the only difference between the two formulas is that little comma over there, which is just basically putting the length string inside the columns parameter inside the sequence instead of the rows. And then basically to test that, I can then go and say, well, leave this blank because it's optional, or put any value in it. And if it has a value, it throws it over columns. But if it's empty or omitted, it will pull it over rows. So I just wanted to show how simple it actually is to create that lambda. The syntax is not difficult, and it is possible to create that quickly on the fly if you needed to, instead of having to write that multiple times or having to copy that multiple times. Or as you go from level 1 to level 5, your formula becomes bigger and bigger and bigger and more difficult to handle, or you need to use this mid-sequence length combination multiple times within in the same formula. Then you can just use split string, and you've got it. So just wanted to show that is also a possibility. And what's cool about it is, in this case, you want to sum it up. So sorry if I'm jumping ahead, but I'll basically just say, well, convert that convert that into numbers, and then sum those numbers for me. And there's my answer for game 1. And that's how simple it is, right? If I had omitted the double dash, it would see it as string, and it won't count any ones. And that's why I just put the little double dash. You could also use the value function, and you can also use. There's another method to take it to numbers. So
times 1.
Times 1. Yeah, you could use times 1 as well, because that implies a mathematical calculation on the numbers. But I just wanted to show that's also a nice tool in your belt, because you probably use this more than you think.
Now, the first time I did it, I used the formula where I just take the length and then minus the length, where I take the string and substitute the ones out, and then just count how many lengths that the character reduced by, the string reduced by.
Also, another cool trick that we've learned over the years. Now,
Steyn, I think you taught me that trick on a previous case, and funny enough, that's exactly what I did for level 1. I just said, what's the length of that string if I substitute 0 for blank? What's the length of the string? Because essentially that's just going to give me 1 blank 1 blank 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 1, and it's just the length of 3. So funny enough, I actually did exactly what you did, as your sort of cool hack that you taught me a couple of months ago, I want to say. But I will say in hindsight that this approach then didn't allow you to scale quickly in the future rounds, because it wasn't really that valuable. It was a quick one to get out because it's kind of like you know the formula, but having the mid-sequence thing going already by the time you get to the subsequent ones may have been slightly quicker, I guess, in terms of time saving later. But you and I seem to be on the same page about what we did. So level 1 actually fairly straightforward. I think if you could split out the text, or if you knew the sort of substitute trick, pretty quick to get out. Level 2, I introduced 100 characters. So you're working on a 10 by 10 grid. I gave an example, a screenshot on the side. Hopefully people are appreciative of keeping column A and row 1 blank, as we will find out later when you're trying to figure out what the neighbors are, because we've had Excel esports cases in the past where the grid starts at A1, and then if you need to look around the cell, then you get lots of errors, and you mess up everything that you're doing. So I tried to be a little bit kinder, but I do know that starting in B2 is maybe not intuitive for some people. And so hopefully I didn't throw too many people off. But anyway, you've now got a string of 100 characters, and the next sort of trick was to say, I need to wrap this into a box of 10 by 10. And so sorry, I need to reread the thing. Oh, level 2, I actually asked just to make sure people understood that the wrapping was going in rows as opposed to going in columns. Level 2, I said, well, if I give you the third row, how many ones and zeros are there in that row? And so in the example, I sort of highlighted in red, that you want those 10 characters, which are characters 21 to 30 in the string. And so I actually built on the level 1 approach with the length and substitute that we discussed previously. Also take the mid of the take sort of combining mid here. Take the mid of the text and then multiply it by row 3 minus 1, because you start at 21 to 30 is the string that you want, plus 1, and then give me 10 characters. And then I did the length substitute thing. Again, I think if you'd started bringing in the split string, Renier, I'm going to call it, because I think we now know what that is, and it's a good name. If you had the split string, you could have looked up, for example, some 21 to 30 or whatever of the values in that cell. How did you guys approach this one?
So I like your method because it's simple. But I did it a lot differently. And essentially what I did was what I just wanted to show is that you can actually use index as well. Once you've got an array, you can refer to a row or a column in that array with the index function. So what I did was I defined my string, and when I was doing this, I hadn't created my split string yet. Otherwise, I could have just replaced that whole portion with the split string function. But then what I did next was I called it block, and then I basically just said block is wrap rows of string by 10. So wrap that string into rows with the length of 10, and then essentially just did a sum on an index of that block, referring to the row number which corresponds with that number. So essentially, this little double dash, like I said, converts it into numbers, and then I define the block and extract the row from that block and do a sum on that. I extract the row using the index function. So that's cool, just for people to know that an index gives you the ability to define a row and or column. If you define a row and a column, you're gonna get back one cell. But if you just define the row without the column number, you actually get the whole row returned to you. So then you basically can refer to exactly what you want and what you need. Again, what's cool about this function is the fact that I used this length to start with level 1. So you can see that it's just a little bit of an addition to my let. I just introduced the index and the block principle from level 1 to level 2, so I could copy paste the exact same function over and just add one more step. And I just wanted to again highlight the significance and the power of the let function, because it gives you the ability to work with information and break it up and split it over rows so that it's understandable. And I mean, if someone with a little bit of Excel knowledge reads this and reads it once or twice, they'll understand it immediately, as opposed to a massive sum if wrapped in another sum if wrapped in another. That's very difficult to audit. This is a lot simpler. So I just wanted to show that.
Yeah, on my first attempt, I also used a complex formula where I take basically row 3 would start at cell 21 up to 30. So I did basically row -1 multiplied by 10 plus 1. But what I realized now is an easy way to get your string is take the row times 10, and then you take the left of the string for that. So for the first one, you do left 3 times 10, which is 30, and then you just do a right 10 on that string. And then you have the 10 string, and then you can just apply your first level formula again on it.
Yeah, the right, obviously working backwards. Then that's quite clever. Yeah, that's I didn't think of that. That's cool. Yeah, Renier, I think the index, knowing that you can leave one of the two arguments blank and return the entire row or the entire column, that as a tool is incredibly helpful in real life. I mean, that index with a 0 or a blank in one of the two arguments is something that I use regularly. It's a really cool hack to know. Unlike some of the hacks that we all know that are more sort of Excel esports related, that one to me is like a genuine, like very useful in day-to-day Excel use. Yeah. Anyway, let's move on to level 3. So level 3, we were given a string. You had to put it into the grid, and then you had to start using this 10 by 10 grid that we provided. And I'd asked what is the active cell? Is it? Oh, sorry, I gave a cell reference. Is the cell active or inactive? Steyn, maybe start with you this time. Do you want to take us through what you did on this level?
Yes, I can. Yeah, you can see my screen.
Yeah.
So what I did is I used my formula from the previous level to get where I calculated from self, for example, take the row less 1 multiplied by 10. But I used the indirect function to calculate what row I'm using and what value is using. And then I calculated that. But now I realize there's probably easier ways to do it, because I think I was staying in a formula too long, whereas I could quicker have gone to this format and then use this one to more easily determine it.
Cool. Renier, how did you tackle level 3?
Sorry, I'm busy playing with VBA now because of you. So level 3, I essentially quickly took into a data table because I'm comfortable with it. So I used your supplied grid 10 empty sheet, which is awesome because it already gives you a named range as well, which is awesome. So you could have just copied that across. And a quick trick to copy, you can just press Control, click your sheet, and pull it to wherever you want to copy it, and it'll copy it across. So I, for level 3, use that exact setup, copy pasted example 3 across from the case sheet, and then just did an X lookup to return both the cell reference and the string. And then essentially all I did was I just did the indirect after I've wrapped it. So and this exact same function is the function that I used for level 2. So again, I could just copy that across from the level 2 logic, which gave me a visual indication so that I can visually see whether I'm doing the right thing or not. And then I could just do the indirect of that cell, because it's contained within the same sheet. I don't need to do a sheet reference. It's just the cell. So it's just going to return for me J10, which is a 1, and then did a sequence of 20 starting from 31, wrap that in a data table with a column index or column reference of example 3. So I think it took me a minute or two because I'm so used to it and because this setup was there for me. And I had a visual check to see, am I doing it right? So that's why I like this. And then the big reason why I think this is also a cool use, this is also cool, is the fact that if you build your X lookup, and I think I only did it from level 4 onwards, but if you build your X lookup to look from example 1 all the way through to game 120, you basically pre-build yourself a setup for level 4, 5, 6, and 7. So I literally just copied level 3 to level 4, same thing, level 6, same thing, level 7, same thing. I'm just building on the logic, but I never have to do things over again. I use the same logic going through. So that's why I'm a big fan of the data table in cases like this.
Yeah, I think that's really cool. And I think, Renier, on your side, I think you are showing really nicely the power of being able to scale as you go through the various levels. Yeah. That sometimes is case specific. Not all of the cases that we see are designed to scale over time. This one certainly was designed to scale. I intentionally was trying to walk people through building up to get to bonus 5, essentially, right? And so being able to start scaling and building from the get-go was a really good idea. I thought I'd share what I did briefly, not because I think it's a particularly efficient approach for this case, but I think it's a useful tip to know for these kinds of cases where you've got a grid or a map or something like that, and you need coordinates. Something I've seen before. So obviously when I was testing this thing out, I was trying all sorts of random approaches to things, and you can see I'm certainly not scaling my answers, but something that I think is quite useful to know just as a tactic for these cases is I created a duplicate of grid 10, as you said, hold down control, just drag it across, create a duplicate, and I created a grid which has got the actual coordinates just mapped out, right? So if you use the address function and you give it the row of the cell and the column of the cell, and I just set the to be a relative reference, copy that across the 100 cells. I've now got a grid that maps out the coordinates per cell. And as I say, this I don't think was necessary, to be honest, in this case, but I think it's a useful tip to know. And if you then convert this into a column, just a straight 2 col, which I did over here. So let me just 2 col grid 10 ref. Then you get I've got something spilling here. Let's try here. Yeah. Then you've got the row 2, B, C, D, E, F, G, and then row 3, B, C, D, E, F, G, whatever with the coordinates. And then I did an X match on the cell that I was looking for to find the position, and then just took the mid of the text string for that position, 1 character. Again, I think this is a really inefficient way to do it in a sort of an esports case, but a nice method to know about for some of these cases where you've got coordinates and things like that, and it's not sort of scaling as naturally. All right, I'm going to move on to level 4. Level 4 for me was the first time that I broke out into a separate sheet and started following more of a data table approach. Level 4 asks, if you're given a specific cell, in this case C6, how many neighbors does that cell have? I guess this is not that complex if you know about the offset function, and you know to offset, go back 1 column and up 1 column and then give it a 3x3 grid. The only sort of trick that may have caught some people out is that if you just sum up that range, then you count the active cell as well. In fact, I did that, and when we were testing the case, realized that I hadn't corrected that. So you have to subtract whatever the active cell is, whether it's a 1 or a 0. But essentially, this is where I broke away into a separate sheet for level 4. You sort of fairly standard approach. Gave a reference to look up example 4. Just did an X lookup on the case for example 4 to pull in the string that I need, and the same thing to pull in the cell that I need with an X lookup. Then I used Renier exactly what you've described, a wrap rows to sort of put the ones and zeros into the 10 by 10 grid that we'd provided, and then did an offset. So if you take the sum offset indirect of the cell reference, so C6 indirect of C6 is going to take me to here, the cell over here. If I then do an offset -1, -1, -1 row, -1 column, and then give it a width of 3 and a height of 3, essentially what Excel is saying is go to C6, go back 1, up 1, go across 3, go down 3. That's the range that I'm going to sum up. And then I just subtracted the actual value of the indirect of cell C6, because if C6 is a 1, it's going to add to my sum value. If it's 0, it's not going to add to my sum value, and then I'm just getting the neighbors anyway. And then I put that in a data table and just ran the table. Ran the table from there to populate the answers for level 4. Do you guys have different approaches there?
I did exactly the same thing that you did. The only addition to what you did was I just wanted a little bit of a visual again. I just put my offset in there just to visually also check my answer while I'm working. So exactly the same function. What's interesting is we've got exactly the same setup. I mean, you also did it in column N, row 2, and P and Q. It's very interesting. But the only addition is I just put the little offset in there so that I can quickly go and check whether my answer makes sense. That's the only addition.
Yeah, no, I did a different approach. I didn't use a data table. Yes. So I converted my coordinate to determine what the position is, and then I realized the row above it would be 10 smaller, 11 smaller, 9 smaller. This one would be 1 smaller, 1 bigger, 9 bigger, 10 bigger, and 11 bigger. So then I could get the positions of those, then I just had to build in additional logic so that if this row is on the first row, then there can't be something above it. Or if it's on column 1, you can't look at column 10. And then what I did is I just extracted the mid each of these values from the string and then just added them up.
Now you're just being on purpose. You just want to be different. I'm joking, but I like that approach. The cool thing about that approach is the fact that it's very programming based. I've also seen similar approaches from Bo. In some of the cases that he's done, he also uses that logic where if you're going up, you're adding 11, and up or down, you're adding 11, etc. And that's for navigation cases. So I know that he's got a very cool formula that nobody understands except him and maybe Dim, where he basically does that math to determine where you're moving towards with the arrows. Instead of saying, what do you do with the row and the column, he just goes and sums a number, adds a number, or subtracts a number to actually get to the reference. And very powerful. If you can understand that and wrap your head around it, a very powerful method, especially from a programming perspective as well.
Yeah, I think in the old model of days, they used to have a competition to see how you could answer the question with the shortest formula, and this sort of plays into that bucket, right? So instead of having to do an offset minus 1, comma 3, comma 3, if you just say plus 11, then the number of characters that you are talking about obviously reduces substantially. So maybe we should suggest to Andrew and team to bring that back into the FMWC or the Road to Las Vegas or whatever it is.
Yeah, it's a nice challenge. I think
it's a cool challenge,
something that,
really cool.
that I'd like to participate in as well, because it makes you think about ways to do things differently and properly, and also to shorten, because sometimes you just can't go short. But if you have those little optimizations in your functions, it just makes it shorter to work with, easier to audit, I guess, as well.
Yeah.
So what you're saying is do everything in named ranges, and then you just equals text string.
Exactly what I'm saying.
I think, and actually your lambdas would throw you out, because you could just say, give the lambda a name like L, and then say equals L cell reference, and then it gives you the answer. I seem to think that, because obviously lambdas weren't a thing back then, but named ranges were, and I seem to think you weren't allowed to use named ranges, but I speak under correction. Anyway, let's move on to level 5. I guess somewhat different for this case to what we normally see is that I decided to make level 5 easy in terms of the perceived difficulty by the author of the case, because sometimes the author's perception of what's easy and difficult doesn't match up with the participant's perception of what's easy and difficult. But anyway, perception of this was that it was easy again. And so levels 1 to 4 were really about splitting out the text string and getting the grid going and figuring out where you are in the grid. And level 5 now trying to figure out if you understand how the neighbors start to play in and how the rules start to play in. So what we did, we explained to the participants on Saturday, we gave a little bit of a briefing for each case ahead before they started. And we said to them, well, look, the rules, they might sound complicated, but they actually only start applying from level 5. So if it sounds hectic, first ignore it and just get through level 4. But also know that level 5 is considered easy. So if you get stuck up above, jump down to level 5, which was a little bit nuanced from what we normally do in these kinds of cases. Anyway, so this is really just simplistically testing whether you understand the rules around what happens after one turn, depending on the number of neighbors a specific cell has got, and whether that cell is active or inactive. And so we gave the cell status, active or inactive, and then how many neighbors, and then basically with ones and zeros, are you active or inactive on the next turn. What I ended up doing, which ended up being quite helpful for me, was I actually just created myself a rules table and basically said there's you are either active or inactive at the starting turn, and you can either have 0, 1, 2, 3, 4, 5, 6, 7 or 8 neighbors, and just really just manually hard-coded, if you're inactive, you only become active in the next turn if you've got exactly 3 neighbors. And if you're active, then you're only still active on the next turn if you've got 2 or 3 neighbors. And I ended up just using this table to basically just do a lookup. And it actually I think worked out quite well for me and was actually quite helpful later on. So I converted the text of active or inactive just using an if into a 1 or a 0, and then to test how many. To test whether the cell was active or inactive on the next turn, because of the way that I'd structured the table, I just use the index of T rules, and then whether you are whatever the active status was +1. So if you were inactive, take the first column. If you were active, take the second column. So 0 + 1 or 1 + 1. And then how many neighbors have you got? If you've got 0 neighbors, then start on row 1. So 0 + 1. If you've got 1 neighbor, look in row 2. And so this was just literally a two-way index, 2D index lookup to get whether you're active or inactive. And actually this, I think, worked out quite well for me then to be able to use that going forward. Interested, Steyn, maybe from your side, what did you do on level 5?
I used the LED formula where I took in the status and the number of neighbors, and then I just used the if formula. So if it's neighbors is above 3, then it dies. If it's below 2, then it dies. Otherwise, I check if it's a 3, then it's alive. Otherwise, just use the original status. Mm-hmm. And that formula I could also carry forward on all the other levels.
Nice. Yeah, Great approach.
So I did it completely manually. And the reason why I did it was just to wrap my head around the rules first, so that I can see if I know the rules. And I think that was possibly the fastest method, in my opinion. Because to run through the 10 quickly, if you understand the logic, literally takes less than 30 seconds, I guess.
Yeah.
And I also
So you just
used
went
the
and
let.
typed in the answers
I
directly.
typed in the answers
Yeah.
directly. Yeah.
Yeah.
I read inactive 6, it's dead, right?
Yeah.
I knew inactive with 3 is alive. So all the inactives I could do quickly. There was only one inactive with 3, and that was the last game. And in the actives, I knew that if it's 3 or 2, it stays active. Anything else would go inactive. So I think I quickly did it. Maybe it even took me 10 seconds after I read the rules. And then I only applied more like a logic later on. So I guess it doesn't matter when you write that logic in this case, because it's considered an easy question and quick to run through, just to make sure that you understand the rules.
Well, I think it does matter, because the time you could have spent writing the logic, you spent later writing the logic. So
Okay,
the 10
maybe.
seconds you basically took here is 10 seconds that you could have saved
Look,
by writing the logic earlier.
I'll give it to you. I think the only thing that I maybe one up you on, Steyn, but maybe you surprise me. But knowing you, maybe not. Is instead of if, I used ifs, so that I didn't have to use multiple ifs. So I did exactly the same thing that you described. I used the let and the cell and the neighbors based off of the cell with the sum offset thingy, minus the cell, and then used ifs to bring in the logic of if a cell is 0 and neighbors is 3, it becomes 1. If it's 0, neighbors is not 3, it stays 0. If it's less than 1 or more than 4, it's 0. Otherwise, it's 1. And that logic that could persist. I used that throughout level 7 and bonus 5 as well. So I don't know if you used ifs, but I used ifs.
Nice. Yeah. The thing that I love about this, and I think we say this on every walkthrough we do, but the number of ways to solve these questions is just, uncountable. And it's so cool to see how different people approach these things. I think sometimes knowing that you can do things manually, especially if you are pressed for time at the end, is it's like good exam technique to know that, right? And actually, I was joking with the participants after the case on Saturday that I think my case maybe lends itself to one of the most useful cases for doing a rand between right at the end when you were short on time, because in a lot of the levels you needed to put a 1 or a 0, and so if you did a rand between of 1 or 0, you had a 50-50 chance of getting the points, as opposed to normally, like if you're trying to deal with in thousands and you're trying to guess what the number is, then you've got like a 1 in 3,000 chance of getting it right, and sometimes you get really lucky. But if you put a random rand between at the end for 1s and 0s, you had a 50-50 chance of scoring points. So anyway, I guess actually interestingly on the exam technique point, we found out on Saturday chatting to the participants that quite a lot of people, when they're getting short on time, don't go and just choose some of the multiple choice answers. And I appreciate that that's not going to add tremendously to your score, but actually quite a few of the participants ended up scoring a couple of extra points, in the later rounds, where they didn't even attempt the question, but just actually went and filled in the multiple choice just for the sake of it. So I think that's pretty good exam technique. Anyway, let's move on to level 6. So level 6, we're starting to talk about turns. So we've done levels 1 to 4, where you split out text strings and figure out where you are and whether you're active or inactive. Level 5 says if you're active or inactive, and you've got X many neighbors, are you still inactive or active on the next turn, whatever the case is. And so now we're sort of combining that now, taking a string of 100 characters, wrapping it into the grid, and then seeing what or how many active cells are there after one turn. And so for level 6 and level 7, again, I broke out into a separate sheet. I think I ended up just running through both of them together, eventually just sort of building on. But same approach, pull in example 7 as an input, do the XLOOKUP to pull in the text string, and then I started splitting this out. So same approach, wrap the rows to get the initial grid, and then I created my first turn grid by pulling in the ones and zeros from this calculation string that I did. And so I built this out with a bit of logic. I guess the sort of two-col stuff we've spoken about, this grid reference we've spoken about, but the number of neighbors, I started now combining what I did for, was it level 4 and 5, I think, together, using the sum offset of the range reference to put me into the grid where I was, offset, give me a 3x3 grid, subtract whether I'm active or inactive, and that would tell me how many neighbors there are. And then using the rules that I set up for level 5, what is the cell now? And I basically then run through all of the 100 cells, and that's essentially my ones and zeros after turn 1. And then for the grid, just do a wrap rows of that column to give me the new grid. And so basically what this is saying is, if you take this grid and go one turn, you end up with this grid. And then you can apply the same logic. Then you go one turn, you end up with this grid. Go one turn, you end up with this grid. And so this logic for me applied for level 6 and level 7. So level 6 was 1 turn, level 7 was 3 turns. And then I could just do a big data table. In fact, I did example 6 and 7 in one big data table. And in the first one, I just pulled how many active cells there are after 1 turn, and in the second one after 3 turns, just by sort of replicating the logic. And that sort of layout setup gave me both levels 6 and 7 in this case. Sorry, I'm talking without my screen, I think. You guys couldn't see my screen here.
You explain it very well. Can I share my screen?
Yeah, go for it.
So yeah, initially when I did it, I also did level 6 and 7 in the same data in the same sheet. But because of the setup, it was easy for me to, in this case, pull level 7 across, just change it to example 7, and I just copy paste it. So use the exact same logic that I showed earlier, just to refer back up to the starting block, and then essentially just did a sum of that range. But this setup helped me quite a lot, because I could use that same logic when it came to level 7 to just copy paste it in the exact same shape, copy paste it down as many times as I needed it to, and it will always refer back to that number of cells higher, and then just moved my little sum function down to turn 3. So that was essentially the two setups for me. And I think that was a pretty simple method. I think the only way that you could potentially make it simpler, but actually it's more complex to write, is to potentially use a recursive lambda. Steyn, did you do it differently?
Well, I had my original sheet, and then I had 10 1 sheet, 10 2 sheet, and 10 3 sheet, with each referencing the previous sheet. But it would have probably been easier just to put the numbers below each other.
Yeah. Yeah, that sheet method is what I used for bonus 5. So I guess we'll still get to that. But I guess that covers level 6 and 7, unless you guys have anything else to add. So you're muted, Jason.
Our level 6 looks very similar, and I also duplicated the grid and just sort of ran it down the sheet. Yeah, so very, very similar approach. And I think 6 and 7 then kind of covers, you just instead of doing it once, you do it 3 times. Yeah, so that takes us through the sort of body of the questions. Let's run through the bonus questions. Let me not forget to share my screen this time. Bonus 1 was how many active cells are there on grid 100 before any turns. This was pretty straightforward. You could just sum, and in fact, I'd already named the range grid 100. I think it was already named in the case. And so you could just sum grid 100, and grid 100 had that SAEC 2024 text. Just sum that up, you get 138. Fairly straightforward. Anything to add to that one from you guys?
No. That's. I don't think you can do it simpler than that.
Yeah. Bonus 2 was a little bit nuanced, sort of separate, a bit abstract from the question. But I said that there's a bonus 2 tab which was given, and this is really just to see if you've kind of started to develop the logic of how the game of life actually works. And so this is now completely separate and completely independent of the rest of the case. But on the bonus 2 tab, you were given a grid of 5 by 5, a grid with 3 active cells in the middle as a horizontal line. What does that do as you iterate through the turns? And essentially, the way that given the rules, this starting cell has only got 1 neighbor, so it will die. The outside cell has got 1 neighbor, so it will die. The middle cell has got 2 neighbors and is active, so it will stay alive. And then these 2 cells that are directly above have got 3 neighbors, so they will become alive. And essentially, if you see this pattern of a little line in the game of life, actually, if you go and run it, then basically this thing just iterates by flipping horizontally, vertically, horizontally, vertically. That's all it does. It becomes a bit of a stable loop. And so this was more a bit of a fun question to see if have you started to sort of internalize the rules a bit, and just said, on the bonus 2 tab, after 3 turns, are you horizontal or vertical? And so turn 1 is vertical, turn 2 horizontal, turn 3 vertical. A pretty sort of abstract question in the case. I don't know if there's much more to say than that.
Well, just that you can use the same logic that you applied on level 6 and 7 to apply it on the smaller grid to see the nuances. Initially, I did it manually. When I did it again, I used the copy down logic that we applied on bonus on level 6, and I could see that iteration where it went vertical, horizontal, vertical, horizontal, but in the end, again, if you're working under pressure and you're running out of time, it's a 50-50. So you could have guessed, and you had a good chance of guessing right. So in cases like this, participants need to know that that's 30 points that you could guess with a 50-50. So more people should have gotten that.
Yeah. Right. Level 3 said if you pick up all of the text strings from level 1 to 7, excluding examples, there was 1 text string that was duplicated. And so I guess level 1 had strings of 10 characters, but all the others had strings of 100 characters. Which string was duplicated? And I approached this question using a VStack method. So I just did a VStack and then went and highlighted each of the 7 level arrays. Oh, sorry, so there were 6 because level 5 didn't have a text string. So there were 6 arrays. So, essentially just went equals VStack and then went to the case and highlighted. And I sort of just highlighted this manually. I don't know if there's a better way to do this, but anyway, went through. And then that gave me the grid of all the text strings. And then I actually just did a pretty traditional highlighted duplicates using conditional formatting and found the red one and copied and pasted values. And that was it for me. Did you guys do something different there?
I just ran the duplicate conditional formatting on the original case.
Okay, so you were applying your mind as to whether one of the examples got highlighted, which I don't know if was that the case or not.
No, there was only the one.
Okay. So
The
that
string was the only way
that
to
was even
calculate.
easier. Okay.
Yeah, so initially I did it in your way, Jason. After speaking to Steyn, I also tried the conditional formatting method, and that's very cool because you could quickly visually just find your answer and just sort of link to it. But luckily in this case, the VStack would have helped you for bonus 4. So you could have applied that same VStack. You could have used that same VStack for bonus 4, which meant that you didn't waste your time sort of building that VStack.
Yeah. So you'll see mine is labeled B3, B4, this tab. And I used the same thing for each. So I had this single array. The nice thing about VStack is now I've got one array, which is quite helpful. And then actually getting a little bit of benefit back from what I did earlier on level 1. You can actually do this in one formula. Some length substitute A1 hash because I've got one array, and substitute the zeros for blanks. So then if you take the length of each of those strings in the array and just sum them up, then you get the answer, which was actually quite quick to do.
Oh, that's very cool. Like it.
Cool. Let's move on to then bonus 5, which was, I guess, the sort of ultimate end goal of the case, and required a little bit of iteration or recursion or just building out more of what we did under level 6 and level 7, but on that 100 by 100 grid rather than the 10 by 10 grid. So sort of a little bit more real estate required in the case. And I ended up doing this on a B5 tab, but the logic very much the same. So start off with that grid 100 starting point, and I just went all the way down the sheet. So I just basically copied and pasted that thing 10. How many times did I have to do this again? I forgot. 10 turns. Yeah, copied and pasted it 10 times, and then pulled in the logic that we'd been using previously. So the same logic that I have used previously, but I put this in a let for the sake of this level. So give me whether the active cell is active or inactive, how many neighbors are there, or the neighbors is the grid reference up above here. So this is where the starting in B2 helped me. I was being a bit selfish in designing the case like that. Number of neighbors is the sum of that range minus the active cell, and then applying the rules like where do I end up next. And so this little let function, I basically then could just copy and paste over the grid of 100 and then just duplicate this 9 times more, and then ended up on after however many iterations, after 10 turns, this is how many was left, and then I summed up the cells. And the things on the side are actual screenshots from the actual Game of Life link that I tagged in the case, just to check if I was right. So I went and replicated the SAEC and then went 10 turns and just checked if the thing matched, which it did. So that's how I got level 5 out.
Very cool. I did it a different way, and I think Steyn did it similarly to what I did. So I created a little empty sheet just saying this is my bonus 5.
We're looking at your desktop at the moment. Yeah.
Bad. Wrong screen. That one. So I created a bonus 5 tab, just an empty sheet, and then sort of named them short so that I could easily refer back to them. Then basically made a copy of that same sheet. And in that copy, I selected the block of cells that contains all of the logic, right? And then all I did was I used my same formula that I used in level 6 and 7, etc. So again, you could have made this a lambda, and you could have used that lambda throughout, right? So that would be a single cell referring lambda. And then basically all I did was I referred back to the previous sheets, B2, and then if you have all of the cells selected, you can just go Control Enter, and that would do the calculation and paste the formula across all of those sheets, or all of those cells. And if you kept that highlighted, right, you could basically pull that sheet across. But then I picked up something that is a cool trick that I forgot about. And what I basically wanted to show is you could, and I copied that 10 times. So that's essentially all I did. But what you can do is, so step 9 refers back to step 8, right? And step 10 refers back to step 9. And I just changed that one number, control enter. Change the one number, control enter. So you don't have to go and select the sheet the cells every time, because the cells are selected within the sheet. One up on that, you can actually go and select, let's say, 2 sheets. So once you've done 2, you can go and right click and go move or copy, or you can do the control click and drag. And then you can sort of put it behind after that 10th sheet, say create a copy, and it's going to take some, well, it doesn't take that long, but I can go and rename this sheet to 11 and go and rename this sheet to 12. And what that does is Excel is clever enough. It worked earlier. So it worked earlier. I don't know what I did differently, but it actually was clever enough to refer back to the previous sheet. It didn't refer back to 8. It referred back to 10. I don't know how I did it now. Maybe it was the control click and drag method that referred back, but I didn't need to change the functions after a while.
Wow.
And that was quite a nifty little stumble upon trick that I picked up. But that's the way that I did it. And again, a recursive lambda would be much cooler. But I think Dim said he had something like an over 8,000 or 80,000 calculations it was done. So he almost broke his computer doing this, where this is a bit more lightweight. What I also tend to do in cases like this, where I have multiple data tables, etc., just a little pro tip, you can go into options and you can go into formulas and go switch on partial calculation. And the partial calculation then doesn't calculate on data tables, and it doesn't calculate on Python formulas. So the nice thing about that is basic calculations are still done. And if you see that the calculation is not working, you can quickly press F9 and it calculates. But at least every time you do a copy sheet or whatever, it doesn't need to go and calculate all the data tables again, because once you have more than sort of 2 data tables, it becomes slow, and your whole user experience becomes slow. So your partial calculations is quite helpful. And that was bonus 5.
Can I show you my solution?
Yeah, please.
Renier, just first question. On the formula tab, you also have the calculation options where you can also change those values to automatic partial. So what I did is I created a 10-1 sheet and a 10-2 sheet. My 10-1 sheet referred to the original sheet, and then my 10-2 sheet referred to the first sheet. And then what I did is I took my formula on the sheet 10-1 sheet, and then I said, if this value was 1, refer to the original sheet. If it's not 1, then refer to the 10-2 sheet. So then what I have here, if I have it as 1 here, then it calculates it from this value. And then I turned my calculation to manual. So now I calculated, now this one calculates 10-2. And now this one, I removed the 1 there. Now I do a calculate. Now it calculates to 10-3. And now I calculate, then it does 10-4, 5,
cool,
6, 7, 9. And then there I have my answer.
That's very cool.
Nice. That's very cool.
Nice.
Now, because I realized if I went and created 10 sheets, then it just becomes cumbersome.
Yeah, like what I did. So just for interest's sake, I've been, like I said, I've been working on in VBA a little bit while we were talking. So, I mean, definitely easier ways to do this, right? But just to showcase, if guys were wanting to try the VBA route, I would do it. I would start off with something like this. So I would basically go and ask the person firstly, how many iterations do you want? So with a little input box. So if I just go in F8, I can run through the steps, and basically, firstly, it'll ask me how many iterations of the game of life. So let's say 10, for instance, and then my range is just the defined range that I'm referring to. I'm referring, so I'm writing this in sheet 19, which is my VBA sheet. So my VBA sheet is essentially just that grid 10 copied with a couple of numbers just to sort of test. And then what's also helpful is I've got the watches video open, the watches screen open, and I've got the locals screen open, and I'll just explain what that does quickly. But with watches, what's nice is I can actually watch a variable, so I can actually look at what the variable does as my code steps. So that's quite helpful. If you wanted to watch the row number move or the column number move, you could do the same in the locals window, but just bear with me. So essentially, I said, well, you need three for loops at least. So you need a for loop for the number of iterations. So essentially, for A in this case, 1 to 10, and then the second sort of for loop that you need is maybe for rows, and the third for loop is for columns. Again, like with Excel, there's hundreds of ways to do this. There's possibly a lot shorter ways as well, and you can use variants and arrays and stuff as well. But this was the sort of first natural version method that came to mind. So then I just said, well, my range is row and column 1. And you can see their cell changed to a 0. That first cell is a 0 in row 1 and column 1. And then neighbors, and this is where I started falling short because I still need to sort of figure out this function. I'm not there yet. But just to show how the next step would be to calculate the number of neighbors. And then basically you could just do a case statement or an if statement. And then basically create that logic, and that determines your numbers, and then you determine where you want to put it, and then once you've put it somewhere, you just copy it back. So maybe if I have 20 minutes more, so I would have been able to get that out, but definitely not in a half an hour, unless I work in VBA every single day, and I'm very, very comfortable. So just wanted to showcase. This is sort of what I would do in VBA.
I think it would have been easier to use the Jason's method, where you do the calculations, and then you have your turn 1 result, and you just use VBA to copy the results from turn 1 back into 0, and then just iterate it.
Yeah, that's definitely
I think it's important
a method that's quick. Yeah,
that if you choose a tool to use, that you don't get stuck into just using that tool, because there may be areas where use of 2 tools that you combine gets a more efficient result than trying to force just using 1 tool.
Definitely, and I mean we've seen that previously in cases where, I mean, I'm thinking back of, I think it was Harry Gross who in one of the live cases jumped into VBA, and you could see he spent time debugging his code in the case time, right? And I think, if I'm not mistaken, it was elections are coming. That was the case, and there the issue was that you had to work with cell colors, and he didn't know about the find and replace by format, right? And he was trying to determine what the cell's color is, but the problem is those cells had like gradients over them, so you had to determine the color, the shading, and everything. So there were like 3 or 4 different variables within VBA that you had to work with. And he spent so much time just debugging. I don't think he did well during that case because he chose to use that one tool, and that one tool actually failed him. So I completely agree, Steyn. Like, if I had to build a solution that is scalable and repeatable, I might actually go VBA, but then I know I've got a day or I've got 2 days where I can make sure that it works perfectly. And it's a nice user experience because you can have an input box, and the user feels like they're working with a computer program and not just a table, not just a range. But yes, when you need to get an answer quickly, it's much better to do to use VBA to potentially just copy paste the answer across that many times, and that'll take you maybe 5 or 10 minutes to build.
Yeah, I don't know why my I've been trying to figure this out, but I don't know why it's not working. I'm just going to look it up. But the sort of the sort of hack, I guess, is that you just go and record a macro, right? You just record yourself copying the formulas and pasting values, and then that's the macro. And then the VBA code will be something along the lines of, range.copy and then range.paste Excel special values, and it'll ignore formats and ignore whatever. And it's like quite a sort of big piece of code. But I don't know why it's not working. Maybe it doesn't work on 2D arrays, and I need to go and sort of do a bit of research. But I mean, this very, very, very simplistically, this code here, I think should actually work. Maybe it doesn't work on 2D arrays, but basically you
just need it in. You just need to put them in inverted commas. So just put that grid paste in inverted commas. That's all you need.
Okay, maybe that's the trick. If you make the one, let's see if we run this now. Well, it ran, so maybe that's a good sign. I'm gonna it did work, Renier, you genius.
I know it worked. I can immediately see that, so that's all that's wrong.
because that
just pick one.
That is such a simple formula to paste values. It just says make this range equal this range, and so you just click run, and so yeah, exactly. I mean,
and what's cool is you can call that you can now make that sub a function, right? Yes. And then you can just call that function with a loop. So you could now go and click make a little button to say 100 iterations. And then all you do is
all you do is an input, you
give it an input, and
absolutely,
or you just put a cell number, you just put a cell there to put a number to it, and then you just loop that 100 times or 5 times or 10 times or whatever.
So that's that one line. I mean, I use it all the time, and I forget the sort of inverted commas. But basically, this is what we said earlier. You've got a hard-coded array, and then you've got one array below it which calculates the next turn, and then you just keep overwriting the original thing, and then you just run.
Yeah, and good on you for using named ranges there, because it just makes the code so much simpler. And your references there, so that's awesome.
Yeah. Anyway, we've nerded out a lot on this course.
You just made me look bad. I'm writing like pages of code, and you go grid copy, grid paste. Right.
Look, I didn't have a fancy message box that came up and said how many iterations do you want and whatever, But no.
Do you need that in this competition? No. So, and that's something I learned from Steyn. Like the first couple of times we did it, I had to make a massive mind shift between making things look good, because when you're working in auditing, you want to build a working paper that looks good, right? Because when someone opens it, it shouldn't look like the dog's breakfast. It should look like something that you can present in front of a court of law or whatever, if you had to. But that mind shift to say, I'm working under time pressure and I just need an answer. It doesn't need to look pretty. It just needs to be functional. That is a big mind shift that I think a lot of people need to make when they start this competition as well.
Yeah. Cool. Anyway, I hope you guys enjoyed the case. I hope others did too, and I hope some international players will also pick it up and give it a go.
I'm sure. I'm going to share the video on the international groups as well, and I'm sure there'll be quite a couple of people that are interested. I know that Lorenzo Forti is also going to cover the case on his YouTube channel. He's covering all of the SAEC cases as well. And then, like we always say, Dim is also doing videos, and I think Dim will actually show you a recursive lambda. So if you want the next level of intensity, you go to Dim's page, and I'll also put that link up on the description once I have it. But yeah, thanks, gents. I appreciate your time. It was again wonderfully entertaining to nerd out with you guys, and we'll see each other for the final once that's live. Thanks. Have a nice evening.
Thanks. Cheers, guys.
Right?
Cheers.